Hey there, STEM Chemistry. This is Miss Ruark. This is podcast 9.4, where we're talking about aqueous solutions and acidity, whether something is acidic, basic, or neutral when you make an aqueous solution. So let's get started. Maybe not. I'm hitting the buttons and it's not going anywhere. There we go. Okay, so we've already talked about this, but let's talk about it again. So water will self-ionize. What does that mean? It means that if you get two water molecules next to each other, they're going to trade off a hydrogen ion. So you end up with, from two water molecules, you end up with a hydronium ion and a hydroxide ion, right? In pure water, the concentration of hydronium ions will be equal to, or it will be equal to 1.0 times 10 to the negative 7th. And the concentration of hydroxide ions would be equal to 1.0 times 10 to the negative 7th. Oh my goodness, look, that's the same thing. Okay, well, guess what? If we know that we have hydronium ions and we have hydroxide ions present in this solution and it's neutral, right? We should be able to, if we have equal parts of the two, well, we come up with this thing called the ionization constant of water, which is Kw. And Kw is equal to the concentration of hydronium ions. I guess I should be writing this down here. Kw is equal to the concentration of hydronium ions plus the concentration of hydroxide ion, or not plus, multiplied by. Right? Well, if the concentration for water is 1.0 times 10 to the negative 7th, and we've got that 2 times, okay, this would end up giving us 1.0 times 10 to the negative 14th. And guess what? 1.0 times 10 to the negative 14th, that is your Kw value. Okay, it's your water constant. All right. Well, how do we know if something is neutral, basic, or acidic? Well, if it's neutral, as we just said, it would have the same concentration of hydroxide ions as it would hydronium ions. If it's acidic, it's going to have more of the hydronium ions than it does the hydroxide ions. And if it is basic, it's going to have more hydroxide ions than it does hydronium ions. Okay, well, guess what? We can use that Kw value to find the concentration of the ions. Okay, you want me to show you how? Oh, no, you do. Let's check it out. Okay, so we have a 1.0 times 10 to the negative 4th molar solution of HNO3. It has been prepared for laboratory experiment. They want to know what is the H3O plus, what is the hydronium ion concentration of this solution. All right, well, we know the Kw of this is equal to excuse me. Okay, sorry, I'm jumping the gun. We don't want to do that just yet. Let's go back. Oh, okay. All right, so this right here says to find the hydronium ion concentration of the solution. Well, if we were to take HNO3, nitric acid, and we put it in water, right, what's going to happen is, remember, this is your acid, and this is your base, right? This is your acid because it's a proton donor. So we end up with H3O plus, and then we end up with NO3 negative, right? So this would be your conjugate acid. This is your conjugate base. Conjugate acid, conjugate base. Okay, so it says to calculate the H3O concentration of this solution. Well, we know that we have 1.0 times 10 to the negative 4th of this, all right? And it's a, let's see if it's all balanced out. Yes, it is. It's a 1-to-1 ratio. So if it's a 1-to-1 ratio, then our hydrogen, or our hydronium ion concentration is equal to 1.0 times 10 to the negative 4th HNO3. And we know it's a 1 mole HNO3 to 1 mole of hydronium ion concentration. And so we end up with 1.0 times 10 to the negative 4th hydronium ions. Okay, so that's our answer for part A. Well, we've got our answer for part A. We know it's in water, and it wants us to calculate the concentration of OH ions. Well, guess what? There are no OH ions in here. Okay, so that's where we can pull in this Kw is equal to hydroxide ion concentration times hydronium ion concentration. Okay, so all we have to do is plug in. Well, we know that Kw is equal to 1.0 times 10 to the negative 14th, We're not sure of our hydroxide ion concentration. That's what we're looking for. But we do know that our hydronium ion concentration is 1.0 times 10 to the negative fourth. Okay, all we have to do is divide both sides by 1.0 times 10 to the negative fourth. Sorry. Right, and then when we solve for this, our concentration of OH should be equal to 1.0 times 10 to the negative 10th. And so that gives you your answer for number 2. And so this is another way for you to figure out what your, it's just another way to figure out your hydroxide ion concentrations and your hydronium ion concentrations. Very simple, right? Okay, let's move on. All right, so calculating the ion concentration from pH. We can use the pH to help us find the hydrogen ion concentration. So if we have pH is equal to negative log of hydronium ion or hydrogen ion, to find the concentration of the hydrogen ion or hydronium ion, we would have to take the anti-log of the pH, right? Because pH is the negative log. So in order to get the to rearrange that around, we would have to take the anti-log. And so if we want to know the hydronium ion concentration, we would do the anti-log of the negative pH. So in essence, what we're doing is 10 to the negative pH, right? It's pretty easy. Okay, so determine the hydronium ion concentration of an aqueous solution that has a pH of 4. Okay, so we want to know the hydronium ion concentration of this thing, the anti-log of a negative 4. Okay, well that's the same thing as saying 10 to the negative 4th. So and it's really nice when it comes up nice and neat like this and it's a whole number, right? So this would end up being 1.0 times 10 to the negative 4th molarity is what our hydronium ion concentration is. Okay? Like, oh my gosh, it's so horrible. Don't worry, we're not going to do a whole lot of those. Okay. Let's do another example. It says the pH of a solution is measured and determined to be 7.52. Uh-oh. It's not a pretty number this time. What is the hydronium ion concentration? What is the hydroxide ion concentration? And is the solution acidic or basic? Okay, so let's answer part A first. It just says that it's a solution and the pH of this solution is 7.52. Okay. All right, so if we want to figure out the hydronium ion concentration, we have to take the anti-log of the negative pH, negative 7.52, okay, which we said was the same thing as 10 raised to the negative 7.52 power, right? Okay, well, we're not going to keep it as 1 times 10 to the negative 7.52 because that's just not right. Okay, so figure out what 10 times that is. When you plug it into your calculator, it ends up being 3.0 times 10 to the negative 8th molarity H3O plus. Okay, now if you are unsure of how to get that, bring your calculators to me in class and we'll go through, try to figure out how you get it on your calculator, okay? Alright, so there's your hydronium ion concentration. Now, in order to figure out our hydroxide ion concentration, we'll just use our Kw, H3O plus, and OH minus. Okay, we just plug in for Kw, which is 1.4. I keep wanting to put 1.4. 1.0 times 10 to the negative 14th, and that's equal to 3.0 times 10 to the negative 8th. All that's times the OH concentration. We want to get that by itself, so we're going to divide both sides by 3.0 times 10 to the negative 8th. Okay, that cancels. We're left with OH I can't talk today. The OH or hydroxide ion concentration, and when we put this into our calculator, it tells us that the hydroxide ion concentration would be equal to 3.3 times 10 to the negative 7th molarity. Oh yeah. Okay, now the next question says, is this acidic or basic? I can't speak. Acidic or basic? Okay, if it's acidic or basic. So we look here and we say, well, the pH is greater than 7, so it has to be basic, right? Well, let's check another way. Our hydroxide ion concentration needs to be greater than our hydronium ion concentration in order for it to be basic. And it is. This is a bigger number than this one, so it has to be a basic solution. Simple. Okay. Oh, hey guys, guess what? That's it. All right, so I guess I'll see you in class. Bye.